What's going on, you guys? So today we're going to do repeated DNA sequences. And so the idea behind this is we're going to get a string of DNA bases, and we want to see if any length 10 string of bases is repeated. So in this example here, this one gets repeated there, 3 there, and this one gets repeated here. And so we return a list of the repeated base pairs. So let's think about how we can do this. So what we need to do is we need to look at all windows of length 10 bases, and then count up the occurrences of each one. And then we can return all the occurrences that are greater than 1. So multiple occurrences. So how can we keep track of the count for each sliding window of bases? We can use a hash map. So the key will be the 10 letter base sequence, and the value will be the number of occurrences. So 0, 1, 2, or whatever. So we'll have a string and an int. And so let's think about that. For each 10 letter window, what do we want to do? Well, first let's make repeats map. Let's call it a mutable map of string and int. And so what we're going to do is if window is in repeats map, increment count by 1. Else input window into repeats map and set count to 1. Okay, so now we have repeats map with all of our counts in it, and now we need to return a list of strings. So then we can make repeats equals mutable list of string. And then we can loop over the entries in our repeats map. So we can go key value in repeats map. What are we going to do? We're going to, let's see, if value is greater than 1, repeats dot add key. And then we'll just, we'll return repeats. So not too tough. Let's think about the space-time complexity of this. So if we've got a 100-digit string, there will be how many? There should be 10-digit, wait, let's think. There should be 90, right? So if it's 100, there's n minus 10. There should be 90 10-digit base pairs. So n minus 10 base pairs that we need to iterate over. So it's O of n minus 10, which as n approaches infinity is just O of n. So we've got O of n time complexity. And because these loops aren't nested, it would be like O of n for the first one, and this would be O of the number of entries. So you're adding those two, and then as n goes to infinity, it's just O of n. N plus 1/3 of n is just n. Okay. And space complexity, it's not a recursive function, so the call stack isn't piling up. We're just using a couple variables to store our data. So it's just O of 1 space complexity. Let me know if you guys have anything different for time and space complexity in this one. All right, you guys, let's code this up and see if we can get it working. Make that a var. So we got to think about how we're going to do this. Okay, so for index in we want index to start at 0 and go all the way up, increment by 1 until we get to s.length minus 10 minus. So this is exclusive, so it doesn't include this value. So index, the last value index will take is s.length minus 10. And s.length minus 10 up until s.length minus 1 is the last 10-digit window that we'll check. Okay, yeah, I think that works. Okay, and so what do we want to do here? Let's see. So if, okay, what's going on there? Weird. All right, sequence, we're gonna make sequence, and this will be s.substring from index to index plus 10. And same thing in this function. This second input is not inclusive, it's exclusive. So the actual last contained value will be index plus 9. Okay. If repeats map contains key sequence, so if sequence is in the map, then we want to increment it by 1. Okay, so disregard this for a second, and I'll explain my thought process for that after finishing up this else. So if it doesn't contain sequence, then we want to add it to the map because it's our first time seeing it. So we want to say oops, okay. We want to set it equal to 1. Okay, so for this one, Kotlin, so technically if you call repeats map sequence, this could be null. I mean, yeah, so the way Kotlin sees this, if you don't assert that this is a non-null value, which is what these exclamation points do, Kotlin will complain that this could be null. So we set sequence and then we just didn't set the value for sequence. I don't see how that's possible because we're always setting it to 1 here. So if any of you guys understand this, like how is it possible that this could be null given that we have this else branch and we've checked that the key is present? I don't see how this could be null, but this is what Kotlin complains about. And so we have to do this non-null assertion. Okay. So once we've done that, we're going to make our variable repeats, which is a mutable list of strings. We're going to loop over the entries and add those with a key greater than 1, or with a value greater than 1, and then return. Okay, that should work. Let's see. Okay, there you go, guys. So another way that we could handle this, there's a Kotlin built-in function that handles null values. So we can do give me a second here. Okay, we can set this equal to get or else. We want to get sequence or we want to call a function that always returns 0 and just add 1 to it. So we're going to attempt to get sequence, repeats map sequence. If that's not successful because it's null or it's not present, we're going to return 0, and in both cases we're adding 1. So either we'll be incrementing a value we've seen before, or we'll be setting a new value to 1. So let me just show you this one. Yeah. So that might be a little bit easier to understand. You're automatically taking care of any null cases. So if it's null, we return, this second argument is a function. So anything inside the brackets is a function. In this case, we're just returning 0 always. So yeah, all right guys, that has been repeated DNA sequences. See you later.